looking at the convergence of series, but not alternating series. So for the first one, n squared plus 1 is bigger than n squared. That means that 1 over n squared plus 1 is less than 1 over n squared. If the denominator is bigger, the fraction is smaller. Right, so now we know that every term of the series is smaller than 1 over n squared. But we know that 1 over n squared is convergent. How do we know that? That's by the p-test. So basically, the p-test tells us that if we have 1 over n to the power p, where p is greater than 1, then it's convergent. So by the comparison test, therefore by comparison test, (1 over n squared plus 1 is also convergent. So let's look at the next one. Well, we can do the same sort of thing. So this time n plus 1 is bigger than n. Again, n whole numbers. So that means that 1 over n plus 1 is less than 1 over n. So therefore we know that 1 over n is divergent. So therefore, oh wait a minute, this doesn't work, because I know that 1 over n is divergent. I know that 1 over n plus 1 is smaller than that, but if it's smaller than that, that doesn't help me to know that it's convergent or also divergent. So I can't use the comparison test for this example. I have to go to something else, and the something else is the limit comparison test. So what does the limit comparison test say? Well, if I do, bear with me. So if I do 1 over n plus 1 over 1 over n, and I look at the limit of that as n goes to infinity. Well, I hope you can see that that's the limit of n over n plus 1 as n goes to infinity. And that's equal, if I divide top and bottom by n, I get 1 over 1 plus 1 over n. That is 1. So what we're saying is that 1 over n plus 1 is, as we go to infinity, is the same as 1 over n. Yeah? Their limit is 1. Now, in fact, this number, as long as it is a number, it could be 0.5, it could be a million, it could be any number, not 0, but if it was any number, then because we know that 1 over n is divergent, and we know that the limit as we go to infinity is a number, then the 1 over n plus 1 is also divergent, but that's the limit comparison test. I hope you see the difference. Yeah, I couldn't use the comparison test because 1 over n plus 1 is smaller than 1 over n. 1 over n diverges. So just because something's smaller than something that diverges, we don't know whether it diverges or converges. Now, the last one is again different. And what we're going to look at here is we're going to look at something called the ratio test. And in the ratio test, we do the limit as n goes to infinity, but this time we're doing of the terms in the series. And we look at the absolute value of them. So in this particular case, we want x to the n plus 1 over n plus 1 factorial divided by x to the, that's n plus 2 factorial over n plus 1 factorial. Remember, that's the limit as n goes to infinity. And this will give me x on top, and it will give me n plus 2 on the bottom. Again, we still want the limit as n goes to infinity. Now, I hope you appreciate that it doesn't matter what x is. So x could be 1,000,000. Sorry about that one. X could be 1,000,000, could be any other number. But n plus 2 is the one that's going to infinity. So eventually this is going to go to 0. Therefore, we know that the sum of n equals 1, xn over n plus 1, is convergent. How do we know that? Because as long as this limit is less than 1, then this is like a geometric progression. A geometric progression where the common ratio is less than 1. That has a sum to infinity. And that is convergent. So this is also convergent. I hope that helps.